Hello, math learners! Our lesson for today is about combination. Combination refers to the selection of objects regardless of their order. That is, changing the order of the objects does not create a new combination. For example, how many combinations of the three letters F, B, and O taken two at a time? The three combinations of the three letters F, B, and O taken two at a time are FB, FO, and BO. FB and BF are considered as one combination only. Similarly, FO and OF is one combination, and BO and OB is also one combination. Another example, how many combinations can be made from the letters F, B, and O taken three at a time? There is only one combination that can be made from the letters F, B, and O taken three at a time, and that is FBO only. FBO, FOB, or BFO, BOF, OFB, and OBF are considered as one combination only. The combination of n things or objects taken R at a time can be denoted in different ways. You can have this CNR or NCR or CNR. And let us use the notation for combination in this manner, wherein you have C, N followed by R. In the first example or first illustration, there are three things or three letters taken two at a time. So we can write the illustration in this form, where N is equal to 3 and R is equal to 2. And this combination is equivalent to 3, because you can have only three combinations with the letters F, B, O taken two at a time. Comparing permutation and combination. Combination is an arrangement of objects in which the order is not important, while permutation, the order of the objects matters. So in AB and BA are two different permutations, but they are counted as one and the same in combination. So for AB and BA, it's only one combination. Let us have the combination formula. The number of combinations of n objects taken R at a time is C n R is equal to n factorial over R factorial times the factorial of n minus R. So for example, consider four letters A, B, C, and D taken two at a time. So using the permutation, we have this formula, P and R is equal to n factorial over the factorial of n minus R. So the value of n is 4, R is 2, because that is 2 at a time, is equal to 4 factorial over 4 minus 2 factorial. Using permutation, the answer is 12. Using combination, we have C and R, where n is 4, R is 2. Then replacing 4 to n, 2 to R, then we have the result of 6. So using the combination, there are only 6 ways. Another example, how many ways can you select a committee of 4 students out of 10 students. For the solutions, the arrangement or order of the students chosen is not important. Therefore, this is a combination problem where n is equal to 10 and r is equal to 4. So, this would be the format. C is 10, 4, where n again is 10 and r is 4. So using the formula of combination, which is n factorial is equal to r factorial times the factorial of n minus r, then we have to substitute 10 to n and 4 to r. So 10 factorial, that is 10 factorial, over 4 factorial, 10 minus 4 is 6, so 6 factorial. Then we can expand. 10 factorial is 10 times 9 times 8 times 7 times 6 factorial. Then at the denominator, you have 4 times 3 times 2 times 1 for 4 factorial, and then 6 factorial. You don't have to expand 6 factorial. Anyway, you can cancel 6 factorial in the numerator with the 6 factorial in the denominator. So the answer is 210 ways. You can select a committee of 4 students out of 10 students. Next example. How many triangles can be drawn on a plane using 4 non-collinear points? For the solutions, a triangle is a figure formed by 3 segments joining 3 non-collinear points. So that is our r, which is equal to 3. If there are 4 points, so that's our n is equal to 4 on the plane, then we have C for 3, where n is equal to 4 and r is equal to 3. So applying the formula of combination, we have now 4 factorial over 3 factorial times the factorial of 4 minus 3. And 4 minus 3 is 1. So what we have is 4 factorial times 3 factorial. Then 3 factorial times 1 factorial is simply 3 factorial. So cancel 3 factorial with 3 factorial. So what is left is 4. There are 4 triangles can be drawn on a plane using 4 non-collinear points. Take note, you can use your calculator in directly computing 4 combination using the NCR button. It is usually pressed as shift followed by the division buttons. So for example, 4C3, this is equivalent to C43. Can be calculated by pressing 4, then shift, then the division symbol. Above the division symbol is, you can see the NCR. Then press also 3 and then equals. And it will give you the answer, which is 4. Example number 4. Basketball is the most popular sport in the Philippines. Suppose that in a league, a basketball coach must select 5 starters from a team of 12 players. How many different ways can the coach select 5 starters regardless of their positions? For the solutions, in this case, there are 12 options, so n is equal to 12. To select the starter members composed of 5 players, so r is equal to 5. This is a combination problem because starter member selection need not be ordered. So we have n, which is 12, and r equals 5. So using the formula, we have to substitute 12 to n and 5 to r. 12 minus 5, that is equivalent to 7. So that is 12 factorial over 5 times 7 factorial. So expanding this, we have 12 times 11 times 10 times 9 times 8 times 7 factorial. So at the denominator part, we have 5 factorial times 7 factorial. Cancel 7 factorial. So what we have is 792 ways of choosing 5 starter members out of 12 players. Next example, number 5. A committee of 5 students is to be chosen. A committee of 5 students is to be chosen from 10 boys and 11 girls. How many committees Next example. A committee of 5 students is to be chosen from 10 boys and 11 girls. How many committees can be formed if the committee is to be comprised as follows? A. All are boys. B. There are 2 boys and 3 girls. And C. At least 4 are girls. So, let us have the solution first for letter A. All are boys. So, N is equal to 10 boys. So, from N is equal to 10. So, from N is equal to 10 boys, R is equal to 5 are to be chosen. So, we have C, 10, 5. 10 for N and 5 for R. Then using the formula, we have to substitute 10 to N and 5 to R. And then we have 10 factorial over 10 minus 5 is 5 factorial. So expand 10 factorial so that we can cancel, so that we can simplify. So we have 10, 9, 8, 7, 6, 5 factorial. We have below 5 factorial over 5 factorial. And then for the solution of letter A, in which all are boys, we have N is equal to 10 boys and R is equal to 5, which are to be chosen. So we have C, 10, 5, 10 for N and 5 for R. And then using the formula, so we have 10 here, 10 factorial over 5 factorial times the factorial of 10 minus 5. Then we have 10 factorial over 5 factorial times 5 factorial. And then expand this. So we have 10 times 9 times 8 times 7 times 6 times 5 factorial. Over 5 factorial times 5 factorial. Then cancel. So what we have is 252 ways. Next, for letter B. For 2 boys and 3 girls. Solutions. If there are exactly 2 boys and 3 girls, the number of committees may be determined using the fundamental principle of counting. That is, the number of combinations of 2 boys out of 10 times the number of combinations of 3 girls out of 10. So, what we have is 2 boys from 10 boys and 3 girls from 11 girls in order to have a committee of 5 students. You can solve this using directly the calculator, and the result is 7,425 committees. And for letter C, let's continue. At least 4 are girls. So for the solutions, if there are at least 4 girls, the committee may be formed as follows. 4 girls and 1 boy. So we have 4 girls, that is from 11 girls, and 1 from 10 boys. And we have 5 girls, so 5 from 11 girls. The total number of possible committees is, we have combination of 11-4 times combination of 10-1 and combination plus combination of 11-5, and you can use your calculator for the computation of the combination. Then what we have is 3,762 ways. Now, always remember, since combinations are subsets in which order is not considered, we count combinations when we wish to find the number of committees, teams, or groups of objects or persons that can be chosen from a given set. Next, let us have combination with repetition. The formula is the combination of n plus r minus 1 and n minus 1. So, for example, let us say there are 5 flavors of ice cream: banana, chocolate, lemon, strawberry, and vanilla. We can have 3 scopes. How many variations will there be? For the solutions, let us use letters for the flavors. B for banana, C for chocolate, L for lemon, S for strawberry, V for vanilla. Example selections will include CCC, that is 3 scope of chocolates. BLV, that 1 each of banana, lemon, and vanilla. BVV, that's 1 banana, 2 of vanilla. Take note, there are n is equal to 5 things to choose from, and we choose 3 of them, so that is R. Order does not matter, and we can repeat. So, using the formula, substitute 5 to n, 3 to r, then minus 1, this is constant, then n minus 1, that's 5 minus 1. And this is 5 plus 3 is 8, minus 1 is 7, and 5 minus 1 is 4. So this is combination of 7, 4. So what we have is 35 variations. Do you have questions? If there is none, then see you next time. Bye!